Today we're going to challenge one of the most fundamental things you think you know, the very nature of space itself. We're going to explore a radical hypothesis that asks us to completely rebuild our picture of reality, starting from the ground up. We're throwing out that old idea of a smooth, empty void and replacing it with something, well, something a lot stranger and a whole lot more interesting.
So let's just get right to it. Here's the core idea in a single sentence. Reality isn't smooth. It's built from distinct, separate 3D networks. And here's the kicker. Multiple of these networks can exist in the exact same space at the same time. The consequences of that are just massive. All that quantum weirdness, extra dimensions, even huge cosmic mysteries, they might all just be the result of these hidden layers interacting with each other.
Okay, so to build this new picture of the universe, we first have to kind of deconstruct the old one. We have to stop seeing space as just a passive background, like an empty stage where the play happens. We need to start thinking of it as an active part of the show.
And this is a really fundamental shift. On the left, you've got our everyday intuition, right? Space is this smooth, continuous, empty box that things just move around in. But the new idea, on the right, says that space itself has a structure. It's not a void at all. It's a network, like a grid built from tiny, fundamental units.
This, of course, leads to the big question. If we just toss out the idea of smooth, continuous space, what are we replacing it with? I mean, if it's not an empty void, what are the actual building blocks of the universe? Probably the best way to think about it is like a super high-resolution TV screen. From your couch, the picture looks perfectly smooth, right? Continuous. But if you got a powerful microscope and zoomed way in, you'd see the individual pixels. Well, this theory suggests that space is exactly like that. At the most fundamental level, it's a 3D grid made of nodes. These are like the universe's pixels, and the connections between them. Those connections define the only paths that anything can travel along. So our perception of a smooth, seamless reality is just an illusion of scale.
And that leads us to the next big conceptual leap. In this model, matter isn't some separate thing that you put inside the network. Matter is the network. Think of a particle not as a tiny little ball, but as a stable ripple, a durable pattern of excitement that moves through the nodes, kind of like a knot moving down a rope. It's not in space, it's a configuration of space itself.
All right, so this brings us to the most revolutionary, most mind-bending part of this whole idea. We've just established that our reality is this single 3D network. But what if it's not the only one? What if there are other worlds, entire universes layered right here with us in the same room?
And there's the obvious paradox, isn't it? If you have two physical networks in the exact same spot, wouldn't their nodes just crash into each other? Wouldn't they interfere constantly? I mean, how could they possibly coexist without just making a huge mess? Well, the answer is this really clever trick that only works because space is discrete, not continuous. It's called structural offset. Imagine you have two identical 3D lattices. Let's call them Network A and Network B. You put them in the same volume, but you shift Network B just a tiny bit so its nodes fall perfectly into the empty spaces between the nodes of Network A. They completely miss each other. Structurally, they're invisible to one another, interwoven like two ghosts passing right through each other. This just completely turns the idea of the multiverse on its head. Forget parallel universes being somewhere else in some far-off dimension. This model says they're right here, right now, interwoven with our own reality. They are spatially present in every single cubic inch of our world, but they're structurally invisible because their fundamental points just don't line up with ours.
Now, even though these networks are independent, they aren't totally isolated. The theory suggests that there can be these rare, local connections. Think of them as bridges or couplings between them. And this is profound. A fundamental force, like electromagnetism, might not be some spooky action at a distance in our world. It could just be the local effect of an interaction that's happening through one of these bridges to an adjacent, interwoven network. So we've built this picture of a multi-layered 3D reality. This brings us to the conceptual climax of the whole theory. Where do higher dimensions, like the fourth dimension, come from? The answer is one of the most elegant parts of this entire model.
So here's the bold claim. The fourth dimension is not a new direction you can point to. It's not a place. It's a property that emerges from the relationship between two or more of these 3D networks. It's a relational feature, not an absolute one. Okay, let's walk through this because it's a big one. Imagine you live inside Network A. To you, your grid of nodes looks perfectly normal, perfectly flat. Now imagine the interwoven network B next door has a different internal geometry. Maybe its nodes are stretched out in some places and squeezed together in others relative to your grid. To accurately describe where a point on your grid is relative to a point on that warped grid, you can't just use x, y, and z anymore. You need an extra number, an extra parameter, to account for that geometric difference. That extra parameter, that number you need just to describe the relationship, that is what our math interprets as a fourth dimension.
So here's the crucial takeaway. Dimensionality itself becomes relative. A higher dimension isn't a feature of your space, it's a feature of the relationship between your space and another one. And if the relationship between these layers gets really complex, well, you'd need even more parameters to describe it, and that's how you could get even more dimensions emerging in physics. It makes the whole abstract idea of curled-up extra dimensions feel much more intuitive and structural.
So now we get to the payoff, okay? We've accepted this framework of interwoven 3D networks. So what? How does it actually help us? Well, it turns out this model offers some stunningly simple and intuitive explanations for some of the biggest, weirdest puzzles in both quantum mechanics and cosmology.
This table is a great little cheat sheet. On the left, you've got the mysteries. In the middle, the standard explanation, which is often pretty confusing. And on the right, you have the simple, elegant solution this theory offers. Let's break down a few of these.
Let's start with quantum superposition. In this model, a particle isn't magically in multiple states at once in our reality. No, its true state is a single, well-defined pattern that's just spread out across several of these network layers at the same time. The weirdness of it being in two places at once just vanishes when you realize you're only seeing a shadow, a projection of its true multi-layered existence onto your single layer.
And what about spooky action at a distance? Entanglement is just resolved beautifully. The two particles were never really separate to begin with. They're just two different projections, two shadows in our 3D layer of a single unified object that exists on that deeper, multi-layered level. When you measure one, you aren't sending some faster-than-light signal to the other, you're just observing one facet of a single underlying thing. They only seem correlated because at their foundation, they're still connected. They're still one.
Now let's jump to the cosmic scale. Dark matter becomes almost shockingly simple. It's not some exotic new particle we have to spend billions to find. It's just normal matter, protons, neutrons, electrons, existing in an adjacent interwoven network. We can't see it because the specific bridges that would let light cross over just don't exist between our networks. But its mass still warps the geometry of its own network. And that geometric distortion leaks through and affects our network gravitationally. We feel the pull, but we never see the source. It's matter that's right next door, just structurally invisible.
And what's really cool is how this model can even ground some of our most abstract mathematical tools. You know how in quantum mechanics we use complex numbers with those imaginary parts? Well, in this framework, that imaginary number stops being just a math trick. It could represent something physically real, the actual relational shift or the phase difference between your network layer and another one.
This theory even reframes time itself. In this model, time isn't a fundamental dimension like space. Instead, it's an emergent property. It's just the ordered sequence of the network states changing, one after the other, like frames in a movie. The flow of time is simply us experiencing one discrete state of reality after another.
And that leaves us with one last, really provocative thought to chew on. If time is just the sequence of these network states changing, what is time dilation? You know, the effect where time slows down at high speeds. Could it just be a shift in the synchronization between the layers of reality? Is moving quickly through our space network causing us to fall out of sync with the time network? Now that is something to think about.